Polynomial functions. Our objective in this video is we want to identify polynomial functions. Well, let's start off by discussing what we already know. We already know what a polynomial is. A polynomial is a mathematical expression of one or more algebraic terms, each of which consists of a constant multiplied by one or more variables raised to a non-negative integer power. Okay, in this case, the prefix poly means many, and the suffix or the root nomial means terms. So we have many terms. Okay, here's an example. You might notice this is a quadratic. Okay, we have three algebraic terms here. Constant multiplied by one or more variables in each case. And our exponents are non-negative. If we wanted to, we could put a 1 here. X to the 1, of course, is x. And we could write x to the 0 here. X to the 0 is, of course, 1. So this is an example of a polynomial that's also called a quadratic. Okay, give me a second. Let's shift a few things. Okay, so what is a polynomial function? It's simply a function of the form f of x equals a coefficient times an x with a non-negative integer, a non-negative power, plus a coefficient times an x with a non-negative power, etc., etc., etc. And the reason we start off with n, and then like if this were n were 5, this would be the fourth coefficient attached to the fourth degree here, third, second, first, and then the constant term as an example. Okay, again, our n's are positive integers. Okay, the n here, so these are positive. The n here, the largest exponent, the highest power, is called the function's degree. A sub n minus 1, etc., a sub 2. So these here, these are the coefficients. They are real numbers. And a sub n cannot be 0. We can't have a 0 here and that way. And finally, a sub n, which is the coefficient of the variable to the highest power, right here, is called the leading coefficient. Okay, let's look at some examples of what are polynomial functions and what are not polynomial functions. Well, here's a polynomial function. Okay, real number coefficient, and a real number. And we notice we have positive degrees, 5, 2, and then if you were to put an x here, positive or 0, x to the 0. Okay, I want to note one thing here that we'll kind of touch on in later videos. This is in standard form. So I'll write that down. Okay, standard form, which means that we have the highest degree, the highest exponent first, the largest exponent first, and then it goes down from there. It decreases from right to left. Okay, so powers decrease from left, I think I said right to left. Powers decrease from left to right. I think I misspoke earlier. Now we'll notice we don't have an x to the fourth, so we would say plus 0x to the fourth. We don't have an x cubed, so we would say plus 0x cubed. And we don't have an x, so we would say plus 0x, and that's okay. Those terms, of course, because you're multiplying by 0, 0 out. Okay, here's a second example of a polynomial function. This one is in factored form, And if I were to multiply, you'll see the polynomial here. Let's do g of x. Let's put this equal to negative 3x to the fourth. And I'm going to multiply these two binomials. And I come up with x squared plus x minus 6. And then I'll multiply these two factors. And I'll have a negative 3x to the sixth minus 3x to the fifth plus 18x to the fourth. So this is also a polynomial function. The coefficients are real numbers and the exponents are positive or zero. There are no negative exponents here. And again, you'll note it's in standard form from 6 to 5 to 4. So this is a sixth degree polynomial. We'll talk more about that in upcoming videos. Let's take a look at two examples that are not polynomial functions and why that's the case. Okay, this is negative 3 times the square root of x plus the square root of 2 times x squared plus 5. Well, our coefficients are real numbers. However, if we rewrite the square root of x with a degree, the square root of x is x to the 1/2. So I will continue with the rest of this here, and we'll notice that this is not an integer. Okay, it's not a positive integer or zero. Okay, so this right here means that this entire thing is not a polynomial function because this exponent is not a positive integer or zero. So let's say here, so 1/2 is not a positive integer. Therefore, it's not integer, integer. Did I spell that correctly? No, I did not. Let's spell that correctly. integer. Okay. Now let's take a look at this second example, g of x. Negative 3 over x squared plus the square root of 2x squared plus 5. Well, let's write this. We know that when we have an exponent in the denominator, we can move it to the numerator by putting a negative with the exponent. So I'll rewrite this as negative 3 times x to the negative 2, rules of exponents, plus the square root of 2x squared plus 5. And again, we'll notice right here, okay, when I write this as an exponent in the numerator, this is not positive. So again, this is not a polynomial function because this is not a positive integer. Okay, let's make a note of that as well. Okay, couple of notes just to kind of pull this together for you. A constant function, where f of x equals c, for example, well, as long as c is not 0, it's a polynomial function. Its degree is 0. So this can be f of x equals c times x to the 0. Okay, a positive integer or 0 works just fine here. That's why this is also a polynomial function. A linear function, or a constant function is also a polynomial function, degree 0. A linear function, for example, f of x equals mx plus b, and let's note that our x, we don't write the degree, but it has a degree of 1. Okay, as long as the slope is not 0, because then we get to a constant function, we have a linear function and the degree of this polynomial function is 1 right here. So a linear function is also a polynomial function. And finally, we mentioned this earlier, quadratic function, ax squared plus bx plus c, as long as your coefficient of the x squared term is not 0, which is what's required so that it's a quadratic, is also a polynomial function, and its degree is 2. Okay, we're going to be focused in upcoming videos on polynomial functions of degree 3 or higher. We just want to note that a constant function, which is of degree 0, a linear function, which is of degree 1, and a quadratic function, which is of degree 2, they are also polynomial functions.